Now there is another method to derive the equation of motion, which is graphical method. So to derive first equation, V is equals to ut, we consider Vt graph according to the given figure. As we know that the slope of the Vt graph represents acceleration, which is given by the tan theta. So by the graph, acceleration is equals to tan theta, which is from the diagram AB divided by BC. Now in place of AB, we can substitute AD minus BD. In place of BC, we can substitute OD. So we get AD minus BD divided by OD. From the graph, the value of AD equal to V, which is final velocity. Value of BD equal to U, which is initial velocity. And the value of OD equal to T, which is the time duration. So we get A is equals to V minus U divided by T. As we further simplify it, we get V is equals to U plus AT. This is the first equation of motion by the graphical method. Now, second equation of motion by the graphical method. So, we use the same graph plotted between velocity and the time. Here, this area under the Vt graph and the time axis for the given interval of time will represent displacement. So, to find displacement graphically, we will calculate the area of the trapezium ADOC by this graph. So displacement S is equals to area of trapezium ADOC. Now the area of the trapezium is given by half multiplied by sum of the parallel side, then multiplied by perpendicular distance between the sides. So in this graph, parallel sides are AD and OC, and the perpendicular distance between them OD. So we get S is equals to 1 by 2 in first bracket AD plus OC multiplied by OD. Now in place of AD we can substitute V, and in place of OC we can substitute U, and in place of OD we can substitute T. So we get S is equals to 1 by 2 in bracket V plus U multiplied by T. Now we can substitute the value of V from first equation of motion. So we get S is equals to 1 by 2 in bracket U plus AT plus U multiplied by T. As we further simplify, then we get S is equals to UT plus half AT square, which is the second equation of motion. Now we will also derive the third equation of motion. V square is equals to U square plus 2AS by the graphical method. So the Vt graph will be used to derive this relation also. So here, initial steps are very similar as we use in the derivation of second equation of motion. So area represents the displacement. Area of the trapezium given by S is equals to 1 by 2 V plus U multiplied by T. To derive third equation, we substitute the value of T from first equation of motion, which is T is equals to V minus U divided by A. Now as we further simplify, we get S is equals to 1 by 2 in first bracket V plus U, in second bracket V minus U divided by A. Now as we solve it, we get V square is equals to U square 2AS, which is the third equation of motion. Now finally, we derive an expression for the displacement in nth second by the graphical method. So there is the graph to derive displacement in nth second. In this graph, let initial velocity is U. At time n minus 1, velocity will be Vn minus 1. At time n, velocity will be Vn. So to find the displacement in n second, Initially, we calculate the displacement in n second, then we subtract displacement in n minus 1 second from this value. So we get the displacement in n second. So here, by the graphs, to find displacement in n second, we calculate the area of the trapezium ABOC. Then to find displacement in n minus 1 second, we calculate the area of trapezium OCD. As we subtract area of trapezium OCDE from the area of trapezium ABOC, we get the area of trapezium ABD. So this area ADDE will represent displacement in n seconds. So to find this area, we use the formula 1 by 2 sum of the parallel side multiplied by perpendicular distance between the sides to get the area. So displacement in n second given by 1 by 2 in first bracket Vn, it will be the first parallel side of the trapezium AB plus Vn minus 1, that will be the second parallel side of the trapezium, equal to d, and multiplied by the perpendicular distance between them means in the graph that will be d. Now we will substitute the values. So we get 1 by 2 Vn plus Vn minus 1 multiplied by n in bracket n minus 1. As we further simplify, we get as n is equal to 1 by 2 Vn plus Vn minus 1. Now using first equation of motion, we can find the value of Vn and Vn minus 1, which are Vn is equal to u plus Vn and Vn minus 1 is equal to u plus a in bracket n minus 1. Now as we substitute these values from equation 2 and 3 in equation 1, we get, after simplifying, we get Sn is equal to u plus 2 by 2 in bracket n minus 1, which is the displacement in n bracket. So these are the equations of motion by the graphical method.